Hello.
Hey, Jafri. How's it
Hi,
going?
how are you?
Well, how are you?
I'm good. Okay, so yesterday we did like fourth chapter.
Yep. Yeah,
I
we.
just checked, I think maybe we left two or three, I think.
Yeah, there was only a few left. We left off on.
Okay,
We completed 73.
yeah, so 79 and 81 and 89. Only three left, okay.
Yep.
I had not seen that only three left, otherwise we can complete yesterday. Okay, no problems.
Yeah, and then it
Four
looks like
points.
chapter 5 is just getting into a bunch of those problems dealing with the gases.
Mhm. Okay, now look here, this one. Calculate the volume in ml of 1.420 m NaOH solution. And for this purpose, we can do it like we can do it very fast, or you can do like in any way. Like let's start with you already had opened this one, so I can go to the blank page.
Yep, I got it. I got it printed out actually. I got it printed off.
Okay, okay. So I'm going to the blank page. That's better.
Yep.
Hold on just 1 minute. Let's start with here. I told you like one for example the A part or any part for this acid base reaction. If it is strong acid, strong base, the reaction is going to be, for example, A, and it is NaOH or acid and anything, for example, H2SO4,
Mm-hmm.
and we have like, let's write general reaction. AH, um, for example, I'm taking H2, first of all, let's take HCl in the beginning. HCl, and what is the base is there?
NaOH.
NaOH. Because in this case it is N1, both of them are 1:1 reactions. So I'm writing HCl plus NaOH, and what will be the product?
It'll be
NaCl
yeah NaCl and water.
plus water. So this is 1:1. So I can just write Ma, molarity of acid, Va is equal to Mb Vb. And normally I also write, like, suppose in this case it is 1:1, but maybe another case different. So I'm putting the AB. A is the coefficient of acid in the equation, B is the coefficient of base. In this case, because they are both are same 1:1, so no problem. We can just plug in the value and we can get the answer easily.
All right.
What is the molarity of what we have to figure out?
We have to.
Volume in ml of this one. So I'm going to calculate the VB.
Mm-hmm. Mm-hmm.
VB is equal to what? In this case, the A and B are equal to 1, so I'm not going to use this one. So
Yep.
what is VB?
VB is Ma times Va over
MA times VA over MB.
NB. Yep.
Because small a and small b are 1, so I'm just not using it. Just plug in the value. The molarity of acid is given here,
Mm-hmm.
2.430 molar.
Yep.
Mole means mole liter inverse. Volume of acid is
25 ml.
25.00,
Yep.
4 significant figure ml. And molarity of base is 1.420 mole per liter.
Yep.
So mole per liter is cancel molarity. Only the unit is there, and we can just use the calculator to get the answer.
Yep. Yeah, it looks like they're keeping 4 sig figs, so
Hmm.
we'll do 42.78 ml of base will be needed.
42.78 ml. That's right. So the answer is going to be 42.78 ml.
Yep.
Keeping 4 significant figure.
All right.
Is it clear? And
Yes,
now
sir.
let's go to the next one.
Yep.
What is the
B.
equation for the next one?
We got H2SO4 plus
Mm.
NaOH reacts to form, uh, let's see, is this one going to be sodium, uh, H, yeah, NaHSO4, yeah?
No, no,
No?
Na2SO4.
Na2SO4,
Mm.
okay.
And water. But we have to balance this equation because each sodium needs two sulfate. Am I right? Sorry, each
Mm-hmm.
sulfate needs two sodium ion. So Na2SO4, I am balancing it, making two sodium, and I also have two water molecule. So according to the equation, balance equation, what is the coefficient of H2SO4?
1.
So I am writing coefficient of H2SO4, which is in this case is 1. What is the coefficient of base?
2.
2. So I am taking 2. And now just using the formula MAVA over MBV, sorry, MAVA over A is equal to MBVB over VP. We can do it in lengthy way, calculating mole and then doing, but this is fastest way.
Mm-hmm. Mm-hmm.
So I want the VB. So again the formula is going to MAVA over MB, but also I have now A and B. So MAVA will be with the B, and here it is going to be A. Am I right?
Yes, yes, you're right.
And now just plug in the value. MA is, we have in this case 4.500 molar. VA is how much? 25.
25, yep.
And B is, in our case, base is 2 molecule according to the balance equation.
Mm-hmm.
MB, volume of molarity of base is 1.4200 molar, and the coefficient is 1. So molar cancel, and this is ml, so answer is going to be ml. 2 and 1 are just coefficient. So use the calculator and get the answer.
Yeah, I'm getting for 4 sig figs 158.5 ml, and that's rounded. The 4 is rounded to a 5. 158.5 ml of
158.5,
and that's of sulfuric acid. I'm sorry. No, my apologies. Base,
sorry,
NaOH. NaOH.
So this is the volume of base, NaOH. Okay, that's the answer. 158.5. Is it clear? Now
Yes.
try this by yourself.
Yeah, I don't know
What
why.
is the equation?
I don't know why it was. I don't know why at first I was thinking it was Na sodium
No,
with
you are maybe you're right,
HSO4.
because normally it ionize in 2 steps, but when the base is there, strong base is there, it keeps taking out the hydrogen.
Yeah.
All of them. Okay.
All right.
So what about its equation for the third part, C
Okay,
part?
for C, phosphoric acid. All right, so we have H3PO4 plus sodium hydroxide NaOH reacts to give Na3PO4. Is that right?
Na3PO4, you're right.
Okay. And then plus H2O. So then
Plus H2O. How many H2 then? 3 H2.
let's see. 3 H2O.
Because 3 H are here, so we need 3 OH. So
Yep.
just balancing at 3. It's clear?
Got it. All right.
3 OH and 3 H will make 3 water.
So the
Okay,
the acid to base ratio is 1 acid and 3 base. Yeah.
Because H3, yes, PO4 to NaOH is 1:3. 1:3.
Okay.
And now again using the formula, now I'm directly using VB is equal to MA VA over MB, and here is going to be multiplied by B multiplied by A. MA is how much in the third part?
The molarity
1.50.
1.50. Yep.
Volume is again same 25.00. B is 3 in our this case.
Yep.
MB is 1.420, and the coefficient of acid is 1.
Right.
Molarity cancel, and ML is going to be the answer.
I'm getting 79.23 ml.
How much? 70?
79.23 ml of NaOH.
You're right. You're right. 23 ml. That's
Awesome.
the answer.
Yeah, it's such
Okay.
an easier, simpler way of doing that. That's
Yeah.
the
Just
best
write
way
the
to do it.
equation, look the coefficient, and that's it.
Yep. Yeah, the teacher doesn't even he didn't even teach it like that. He yeah, I
Because
don't know
this
why.
formula is not given in the books. I know these things. These things I just record like to make it fast.
Yeah. It's definitely the way to go.
That's why I say that teaching is a learning process. So even teacher learns when the student do those things.
Yep. Yep. Yeah, I'll definitely be doing that on the test. For sure.
Okay.
Alright. Yeah,
So,
looks like this one here it's got A through J, but we don't have to do all of them. We could do or actually
classify these reactions according to the type discussed in the chapter. What chapter? Okay, just look one example. What type they are discussing this one?
just a second. I'll check the
So I know that what type they are discussing. Because maybe oxidation reduction.
Yep. I'm
Looks oxidation reduction, am I right?
yeah, you're right. I'm just loading up the PDF on my other yeah. Alright, let's see. Yeah, so like precipitation reaction, let's see.
What types? Let me see, so I can decide on that basis. Whatever they have discussed. Maybe precipitation. You're right. Precipitation.
Acid base neutralization.
Okay. Acid base neutralization.
Yeah, the oxidation reduction.
Oxidation reduction. And what else?
Let me see. Combination reaction.
Combination.
Decomposition reaction, combustion.
Composition.
Yep.
Combustion.
Yep.
Okay.
And displacement reaction.
Displacement. And double displacement is also there? Or metathesis, same thing?
Yes, that one was mentioned.
What they are using? Metathesis?
I remember.
Because this is the
I remember seeing that one.
that is called a double displacement. Remember, same thing. Double displacement. Okay, let's start this one. All of them. First of all, let's start with this because I know that's the first one. You are looking 4.81. Am I right?
Yes. Yeah, I got it
So
printed out.
I'm not writing there. Okay, question.
Yep.
Where I will feel necessary, then I'm going to write.
Okay.
4.81a.
Yep.
It do not looks to me like a combustion or decomposition or something like that, but it looks to me oxidation reduction. Why? Because if I look the Cl2, what is the charge on Cl2?
Zero.
Zero. The charge on Cl2 is 0. And after the reaction on the right hand side, what is the charge on Cl?
1 minus.
1 minus. So I know that chlorine is changing from 0 to minus 1, and also at the same time chlorine is changing from 0 to plus 1.
Oh yeah, yeah,
Look
you're
in the
right.
ClO. In the ClO, what is the charge on Cl?
Yeah, +1.
Plus 1. So chlorine is oxidized, chlorine is reduced. So it's an oxidation reduction reaction.
Mm.
So A is what? Oxidation reduction reaction.
All right. Yep, I'm writing. I just wrote that down. All right. And then B. Let's see. So we have calcium ion plus
Hmm.
carbonate ion, and then it's going to. So would this be like a combination reaction,
Okay, this
or it
can
could
be
be
called combination as well as
oxidation
precipitation. No,
oxidation
not
reduction?
oxidation,
No.
no. Okay, the first one is oxidation reduction, A.
Okay.
Because whenever there is oxidation, there is also going to be reduction.
Okay.
Okay, now the B looks, I don't know what they are saying, but it is both. Because
Mm-hmm.
from the ion, if I just look the ion, only one ion, it looks to me addition reaction. But at the same time, I know that calcium carbonate is solid. So it's a precipitation reaction. Let's see
Yeah.
what
Yeah.
they are
You're right.
saying.
Yeah. You're right. You're right. I just looked at the solution manual for B, and it says
Mm.
precipitation reaction.
Yes, because calcium carbonate is solid.
Okay.
Okay. Now the second one, NH3 plus H positive, forming NH4. Now you tell me what is this? What's happening here?
Yeah. It looks
Let me
like.
have a write this here. NH3 plus H positive, forming NH4 positive. This is C. What do you think this one?
Is this
Let me, I will give you a hint,
this
not
one's
the
not
answer.
this one's not an oxidation reduction, is it?
Yes, I don't think so. Now, what is the definition of Bronsted acid
Oh,
and
okay.
Bronsted
So
base?
Bronsted acid is a proton donor, and the Bronsted base is a proton acceptor. Yeah.
Acceptor. So in this case, because ammonia, they are not showing the lone pair, but lone pair is there. And also according to the Lewis definition, base is the lone pair donor and acid is the lone pair acceptor. According to both definition,
Yeah. Yeah.
what's happening here? Ammonia is accepting proton or not? Because H positive
Yeah. It
is
looks like
proton.
it is accepting a H
So
plus.
this one is acting as a base because it's accepting proton, this one is giving proton, and also according to the Lewis, this one is donating lone pair electron, the other one H positive is accepting proton. So that is acid base reaction.
Wow.
And now
Yeah.
one
You're
thing
right.
remember,
You're right. It is. Yep. That's exactly
okay?
what the solution manual is saying. Acid base. Yep.
Yeah. Now let's go to the D. You tell me first.
Okay.
I'm writing, but you have to tell me first. I'm writing the D. Oh, let me, I already have here. So I will write this. This one, right?
Hmm.
D.
I'm looking at it, and it seems like it'd be oxidation
This,
reduction.
okay, if you see one of them is oxidized or reduced, just oxidation reduction. We don't have to waste time.
Okay.
Look the chromium. What is the charge on chromium here?
A 2 minus.
Hmm?
2 minus. Oh, I'm
No,
sorry.
chromium is not so much.
Oxidation number on chromium. Okay. We have -8, so it'd be +8.
Not
No, wait.
positive.
+6? No.
Positive 6. You're
Okay.
right. It's not because look here this one. I'm going to show you this one. We did yesterday. CrO CrO4. I think that the CrO4 was there.
Yeah.
2 negative. So Cr I don't know. Suppose X. So I'm writing X. Oxygen because 4 and -2 8 -8 is equal to -2. So X is going to be +6.
Mm-hmm. Mm-hmm.
Okay. So X is +6. Now let's see what is the chromium on the right hand side.
Chromium on the right side is, let's see, -2, -4. Hold on, minus 2 minus times 2 is -4, and -2 is -6, so it'd be +6. +6.
Now in this case, little bit I have to double check this one, because for example when we have, let me I will show you, KClO3, we know in that case we take -2 times 3, and this one we take +1, and then we take this one is as a +5. Now we have this problem here which has a CrO2Cl2, CrO2Cl2, CrO2Cl2. If I take this one, hold on, this one, what is the reaction here? This is not displacement, and let's see what is here in this case, +1 +2. Assuming this one chlorine as a +1, let's see, +1 times 2, this is going to be -2 times 2, -4, and +2 will give you what? -2. So I think +2. Let me have a double check this one.
Okay.
Hold on. In that case, they are taking oxygen and chlorine is, they are taking -1 -1 as it is, as the binary compound. So if I take that one -1, not the +1, so in that case, if I don't take this, I will take CrO2Cl2 -1 times 2 -2 times 2 -4, then it will be +6, so there will be no change. Am I right?
Right.
If I take this one, then it's going to change. Let's see other thing. Chlorine is negative here. CCl4, I
It's
can
not
take negative.
decomposition, is it? Or no?
No, it's not a decomposition, because decomposition, one thing is breaking. It's not addition. It is not like a acid-base reaction. So the thing is, what reaction you told me others? It's not a precipitation reaction, all of them. If it is like this one, if the chlorine is, I can say it's a +1, then it's going to be oxidation reduction. Just check what they are saying now.
It says the answer is combination reaction, and the explanation that they give is the oxidation numbers of carbon, chlorine, chromium, and oxygen do not change. This is not a redox reaction, and it does not fit easily into any category, but could be considered a combination reaction.
But it's not a combination. Why? Because your combination means two things or more things will come less. Now we have three things.
Right. Yeah.
So basically, I can consider a little bit as a decomposition, but not as a combination.
Yeah, that's a tricky one.
Yeah, so that's do not make sense. The combination. You got 2 and 1 3, and we are getting 2 1 3 1 2 5. We are getting more things. Combination will reduce the things. Okay.
Yeah.
Now we are having more molecule, more things on the right hand side. So I can take it a little bit decomposition. Okay, that's right, because that's not oxidation reduction. Because chlorine they are taking -1, so not changing. Anything is not changing. So it's not that one. So this is I do not agree with combination.
Yeah.
I
Yeah.
say it's like a mix of combination and decomposition. I can say
Got it.
this one is
No worries.
okay.
Yeah, I think for this one, he was.
Like it is combining and then it is breaking. That's happening. Due to combination, they are breaking into another things. Okay, like
Hmm.
that.
Hmm.
Whatever. Okay, now let's read this next one.
Okay.
In this
E
case, what is the charge on Ca?
0.
What is the charge on fluorine?
0.
So calcium is going to +2, fluorine is going to -1. It is an oxidation reduction reaction at the same time is also a combination reaction. See what is they are saying because it comes in both category.
Yep. Yeah, it's saying redox reaction
Redox reaction.
for
So when it
heat.
is redox, just say redox, okay?
Yep.
But it is also a combination because so it's a redox because oxidation reduction. What is the oxidation number here?
For 2Li,
Just Li.
0.
Here it is +1. So even don't look other thing. It's a redox.
Yep. Yep.
Because when there is a reduction or oxidation, other things are definitely going to be there. What about this?
All right.
Now they are changing the partner, am I right?
Right.
NO3 is going with sodium, SO4 is going to this, and also we know that barium sulfate is
Insoluble.
insoluble. So
Right.
it's a precipitation reaction.
Precipitation. Yep.
Of course, it is also a metathesis, exchanging partner, but it's better to say precipitation because solid thing is there. What is the oxidation number of Cu here?
Let me see. Oxygen. Would it be +2?
What is here?
0.
If anyone is changing, just say redox.
Redox. Got it.
Okay.
Zn.
What is the charge on Zn?
Yeah, 0. And then
What is?
this now is +2. Yeah.
I'm not going to look at that, but I know already it is redox.
Mm-hmm.
Anyone change, then it's redox. What is the charge here? Fe.
2+.
What is the charge here? Fe.
Looks like 3+.
So it's changing, so redox. You can check.
All right.
It's redox.
Yeah, it says yeah, it says these last 3 were redox. Yep. And the barium sulfate was precipitation. Yeah, so I'd have to be careful.
Yeah, if you see anyone is changing, anyone, and if they're just asking what is the type, you don't have to waste time for searching other thing. If you see oxidation, if you see reduction, definitely it's going to be redox because oxidation cannot take place without reduction. Reduction cannot take place without oxidation.
Got it.
Okay, now let's go to the fourth one. This one you can ask your teacher also. This one is which one we told you? I told you.
D. Yeah, that one
D.
was.
Yeah, it's not combination. It's like a combination, decomposition, everything is there.
Yeah, that's definitely a lousy problem to give us.
Yeah. Now what about 4.89?
All right, saying which of these aqueous solutions would we expect to be the best conductor of electricity at 25 degrees Celsius? Explain the answer. So.
Okay, first of all, normally dilute solution are better, but also depending on the concentration, how many ions are there, also depend on all these things. The weak acid is not a good conductor.
Not a
first
good
of all.
Yeah.
So this is a weak acid. Okay. This is salt, completely soluble. HCl is also
Completely.
strong acid. NaCl is also soluble salt.
Yeah.
Now we have to compete between NaCl, HCl and this. Which one has higher concentration?
The HCl.
HCl. But so now HCl is going to win from NaCl because we have more ions in it. Okay. But now the problem is here. MgNO3 if you dissolve this one MgNO3 will give you 3 ions. it will gives on dissolving aqueous 1 Mg 2 positive and 2 nitrates. So how many ions you are getting? 3.
3 ions. Okay.
3 ions, 1 and 2, 3. In HCl you are only getting 1 and 1, 2, sorry. So even it is 0.25, you are getting 0.25 mole of this, 0.25 mole of this. So total you can say 0.5, but here you are getting 0.2 times 3, 0.6.
Wow.
Am I right?
You're right.
So this is going to win. So this is going to be the answer.
Wow.
Just check this one.
Yeah, choice D. You're right. It says that
Okay.
says the magnesium nitrate should be the best conductor of electricity. The
Because
total.
it will produce more ions.
Yeah, it says.
Even the concentration is less than this. But each one is producing 3. So 3 times 0.2 is 0.6. This is producing 2. 2 times 0.25 is 0.5. And why I eliminated this in the beginning? Because this is weak acid.
Weak. Yeah. Yep.
Okay, that's
Yeah,
why.
it says the total ion concentration in this solution is 0.60 molar. So, yeah, you explained it perfectly.
Even it looks like this 1.60, but this is not strong. It is going to decompose very less. So
Wow.
we did this completely, okay?
Yep. Yep, and that's it. That covers all of them for that chapter's homework problems.
Okay,
So,
now
I guess.
let me one question I'm asking, okay?
Yep.
I am taking this one. Number 1 I am taking AlNO3 nitrate, aluminum nitrate, sorry 3. And this is concentration is 0.2 molar. Second I am taking calcium nitrate. Concentration is 0.2 molar. Third is HNO3, 0.3 molar. Which one is going to conduct more best conductor of electricity? This solution out of this.
All right, so comparing it to what we did in the last one, I'm thinking this aluminum nitrate. Is that because
You're right.
it'll be
Yes. What will the total ionic concentration in this case?
should be 0.8.
Yes,
Is
because
that true?
4, 1 and 3 nitrate, so it's going to be 0.8 molar ions concentration. What about this one, second one?
0.6 molar.
And what about the last one?
Is that one still 0.6?
No, yes, you're right,
6?
Yes, you're right.
Okay.
Because they also have 2 producing, 0.3 times 2 is 0.6. It's clear?
Yes.
Okay,
Yeah,
now let's go to the chapter 5.
All right.
Your test is going to be 4 and 5, am I right?
It's going to be on chapter 4, 5, and 6, but we haven't covered 6 yet.
I already have had given you in the past, but if you missed that one, I'm going to send you again.
Oh, I got.
Gaseous state formula sheet.
Yeah, I have it still printed out from that time.
Okay.
It starts off
Because we are
with
going to use those things. Okay?
Boyle's law, Charles' law, pressure and temperature, general gas equation.
All the gas formulas, am I right?
Yep. Yeah, I got it. Still.
Okay.
Yep.
Let me open this here. Okay, no problem. So let's go to this one. A gas occupying a volume of. I'm going to just open here and we can go to the blank page.
Yeah,
okay?
I have it printed out. These chapter
So
5s.
that's going to be better. 5 point. What is the question? $5.19. Okay. Now let's start with the 5.19 and first write the data, all the information given directly or indirectly. A
Okay.
gas occupying volume, how much is volume is given there?
725 ml.
725 ml. At a pressure, what is the pressure?
0.970 atmosphere.
70 atmosphere. Okay, in the beginning I don't put 1 and 2. Maybe we need, maybe we don't need. Okay.
Mm-hmm.
If there's two volume, then I'm going to put 1 and 2 subscript.
Okay.
At constant temperature. Temperature is what? Constant. So the
Constant.
temperature
Okay.
constant is telling me that something about Charles law. Okay. The pressure, until its pressure reaches this one. Now the next pressure, their pressure is given another one. So now I'm putting 1 and 2. And when I'm putting 1 and 2, I'm putting the 1 also with the first volume. Okay.
Yes.
So when you see two things, then put 1 and 2 subscript, because that volume is belongs to 0.970, so 1 and 1 subscript. Second one is this one. What is this final volume? V2 we have to figure out. And pressure volume relationship at constant temperature, it means what lies there?
Charles law, you said.
Charles law. Charles law. So we know what is the Charles law is. P1. Okay, I'm
Or
not
is
writing
it
a Charles law.
or is it Boyle's
Okay, I'm
law?
not writing this one, right? I'm writing general gas equation
Okay.
in this form. Now in this form, because the temperature is constant, I'm cancelling. No, temperature is constant. Sorry, I made a mistake. And it's not a Charles law. Sorry. Because temperature is cancelling. And what left now? P1 V1 is equal to
P2
P2
V2.
V2. This is Boyle's law, sorry. Boyle's law. Because pressure and volume relationship at constant temperature is Boyle's law. And even look here. If I don't know what is that formula, I took general gas equation P like this form.
Yep.
Whatever is constant, just cancel it. And then the remaining will be the formula for you.
Got it.
Okay.
Got
So
it.
I got P1, V1, but you can use any unit, but same unit for both pressure and both volume. Now according to this, because they are asking the P2, what is the, no, V2, they are asking final volume. What is the formula now after rearrangement?
V2 is equal to P1 V1 over P2.
Okay, just plug in the value.
Yep.
But make sure the units are same for both pressure. So VP2 is 0. P1 is 0.970. Okay, even before solving the problem,
Yep.
what you expect? Volume is going to be more than 725 or less than 725?
Less.
Less, because look here, what is the pressure in the beginning was more, now the pressure is less. Pressure and volume are inversely relation. If you decrease the pressure, volume is going to increase. So your new volume is going to be more.
Oh, the new volume is going to be more. Okay.
Yeah, because less pressure, more volume.
Got it. Okay.
Your pressure, you are decreasing the pressure. So in case if I press some wrong button on calculator,
Yep.
and my answer is I am getting less than 725, so I know it is wrong, because I am expecting more volume with less pressure.
Pressure is decreasing, so we are expecting.
Volume is going to increase.
Okay. I was just writing that little note down.
Because sometimes we press wrong button, so be careful about this one.
Yep. All right. I'm gonna 725 times 0.970 over 0.541. I'm getting 1299.907.
Yes.
Let's see. We
How
got
many significant figures they are using?
3.
3. So let's give the 3 answer. So I'm putting 1.1299. How I can write 3? First I'm writing as it is. 0.9.
We can do.
Okay. I want to keep only 3.
We could do one. Could we do 1.30
I can only do like this. 1300 like this.
Yeah. Yeah.
Oh, sorry. 3
I was
significant.
1.30 times 10 to the third power.
130 point 0, point like you can say, okay? Or you can say like 1.30 times 10 to the power
3.
1, 2, 3. That's right.
Yep.
And because the answer was in ml, look
ML.
what answer they are giving you.
This one.
This one, because keeping 3 significant figure, okay?
Yep.
That's the better thing.
Yes, sir.
Okay, so be careful about significant figure.
Definitely.
Okay,
for
now
sure.
5, because you don't want to miss a single point.
Yep.
Okay, now
Yeah, I definitely
5.2.
don't want to. I need to make sure I
No, yes, you did excellent. Don't worry about it.
got
That
it.
one.
Yep. Next
Okay,
is
now
21. So they're giving us a volume of gas is 5.8.
volume of gas. Okay, I'm not putting 1 and 2. If I need, I will do it.
Yep.
First, I put just without 1, 2. 5.80 liter.
Yep.
Measured at P 1.00 atmosphere, and they are using 3 significant figure.
Mm-hmm.
What is the pressure of the gas in mm of mercury? They are asking the pressure of gas. If the volume is changed, so because they are giving new volumes, I'm putting P1, P2. They are asking this, but they are asking in of mercury. Am I right?
Yes. Yes. You're right.
So no problem. We can get the ATM and then we can change it, or we can change right now. It's no problem. What is the volume V2
Volume V2 9.65 liters.
liter? Now instead of changing at the end, I already know 1 atmosphere is equal to how many of mercury?
760 millimeters of mercury.
Yes, so millimeter of mercury. So I'm going to use millimeter. What temperature is constant? What law I have to apply?
Boyle's law.
Yes, so P1V1 is equal to P2V2. I can use any unit but same unit for both pressure and volume. So V2, I have to figure out P2. What is the formula now?
P2 is equal to P1 V1 over V2.
Okay, just plug in the value.
All right.
P1 is, but don't use the, otherwise you have to go next step. So I'm using 760 directly.
Yeah. How I was thinking.
Look, of mercury, I'm writing the unit. Volume is 5.80 liter, am I right?
Yes.
Liter. Divided by V2, which is 9 point. Okay, without solving it, first tell me,
Mm-hmm.
your pressure is going to be more than 760 you will get, or less?
All right. So since the volume is increasing, that means that our pressure is decreasing.
Yes, so your answer is going to be less than 760. If you get by mistake more than 760, go back and check again, okay?
Yes. All right. So we can include the 760 millimeters of mercury right in the equation. Is that right?
It's better if you write or mercury, otherwise it depends
Yeah.
on your teacher. Because later cancel and it tells you that your unit is going to be.
Oh yeah, yeah. I like that. I like it.
Yes.
Okay. So 760 and 5.80.
Because if I forget the conversion, then I know from here it's going to be wrong. I
Okay.
will get something other unit.
So we're keeping 3 sig figs. It'd be
Mhm.
457 millimeters mercury.
Yes, that's it. It's
All
clear.
right.
And now look, it is less than that.
Yep. Yeah, because one
Any
atmosphere.
question?
Yep.
So always before getting the answer, also see what you're expecting. Do it make sense or not? Because using calculators make easy, but sometimes also we press wrong button and get the wrong answer.
No, you're right. You're right. Yeah, that's definitely the best way to think about it. The best concept. You know.
Okay. Yeah. So now let's start this one. You make the data.
All right.
Before you tell me what to write.
Yep. All right. So we're given the volume. So volume is 36.4 liters,
Mm.
and the temperature, they're given a temperature change. So I guess T1 to T2. So
T1.
T1 is 25 degrees Celsius, and T2 is 88 degrees Celsius. And they're asking, what is the final volume of the gas?
So because 2 volume to 1 and 2. And at constant pressure. So pressure is constant. Now it means now we have to apply Charles' law.
Charles' law. Okay.
Okay, even without doing anything. Problem.
My first thoughts was this. Since
V2 is going to be what? More than 36.4?
More, because we're heating it, right?
More temperature. Yes, right.
Or
Now,
the volume, right?
Do I have to do something with the unit here before solving it?
Yeah, we have to change it to Kelvin. Is that
Kelvin? Yeah, we can do it with Celsius. If you want more accurate, normally we add 273. But if they want more accurate, you can add 273.15. For general purpose, we just add 273. The first one is going to be 298. Second one is going to be 88 plus 273. 361.
Yep.
Otherwise, if you want more accurate, 0.15 you can write.
Yep.
And all of them are now Kelvin. Now you want the you want the V2. Can you rearrange this one?
Yep. So V2 is equal to V1 over T1, but it'd be V1 times T2. So
V1 cross multiplication.
Yep.
V1 T2 over T1. You can go directly, otherwise you can do it like this.
Yep.
V2 T1 is equal to V1 T2 by cross multiplying. Keeping V2 here, send the V2 in the denominator.
Got it.
Okay. Now plug in the value.
Alright, so we got V1 as 36.4. Multiplying it by T2 we got 361, and then we're dividing it by 298 Kelvin, and we're getting, let's see, 1 2 3, should we do 3 sig figs? 44.1 liters.
44.1 liters. Okay.
You agree?
Is clear now?
Yep. Yes, sir. Yep.
And if you want to put the units, so make sure to look here later. We are giving Kelvin, 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 Kelvin cancel, and only liter is there.
Got it.
Now let's go to the next one.
Yep. 4.31. I'm sorry. 5.31.
5.31. Give me the data.
Alright, it says sample of nitrogen gas kept in a container with volume is equal to 2.3 liters.
Okay, volume is 2.3 liter.
Yep. And let's see. Temperature is 32 degrees Celsius. And pressure is 4.7 atmosphere. And it's asking to calculate the number of moles of gas present.
Okay, now look here in this scale.
We could do ideal gas law, yeah?
Yeah, because they are not two pressure, two volume, so we don't have to put subscripts. That's why I don't put the 1, 2 in the beginning and then I adjust 1, 2 subscript. So now we know that, and what is the R value? That's you have to
0.8. I'm sorry, 0.0821
liter atmosphere per degree Kelvin and mole. Do we have to change any unit before solving this one?
Yes, the temperature to Kelvin.
Temperature. So I'm going to add 273, and what you will get?
.305 Kelvin.
305 Kelvin.
All right.
Now we have to calculate N. So can you rearrange this formula for N?
Yep. N is equal to PV over
Hmm.
RT.
That's great. And just plug in the value.
Yep.
Make sure whenever you are doing, always, because your R value tells you what unit you have to use. We have to
Okay.
use the volume in liter. Of course, we have liter now, right now. If you don't have liter, you have to change into liter. You need the pressure in atmosphere. If it is in torr or at millimeter of mercury,
Mm-hmm.
you have to change it into atmosphere. The R value is telling you what unit you need. And of course, temperature is Kelvin.
Yeah, the R
Now,
value is. I was thinking, like, you could check your work to see if you did it right. You could
yeah, so that's
you.
why I'm going to use this one. What is the pressure? 4.7
Yeah.
atmosphere. Volume is 2.3 liter. R is 0.0821. I'm writing liter, atmosphere, Kelvin inverse, mole inverse, per means inverse. Okay.
Mm-hmm.
And now the T is 305 K.
Yep.
Now let's see. K inverse and K cancel. Am I right?
Yes.
Okay. At ATM and ATM is cancel. Liter and liter is cancel. What left here?
Moles inverse.
Mole. And because inverse, if you take it up, it will
Yep.
become mole. Am I right?
Yep. You're right.
So your unit is, it means everything units you are using correct. Now just use the calculator and get the answer.
Yep. 0.43 mole for 2 sig figs. I was getting.
How much you are getting?
0.43 mole.
Oh, maybe I'm wrong. Let me double check.
I'll do it
this
again.
one. Only maybe I'm wrong. 4.7 times 2.3 divided by 0.0821 divided by 305. You are right.
Okay.
I was wrong.
No problem.
How many significant figure I will keep?
I'm thinking 2.
2. So I'm just writing 4.3. Am I right?
Yep. Yeah, going off the
Yes.
volume and then the pressure.
Okay. Now let's try the next one.
Yep.
Help me in making the data.
Yep. 5.31. All right.
3.1
Volume.
or 3.5?
I'm sorry. 3.5. My bad.
Okay, okay.
Yeah, we just did 3.1.
Now, okay, so let's do the 3.5. Tell me the data to write
Alright.
this data.
Volume is 2.50 liter.
Volume is 2.50 liter. Okay.
And then pressure is 1.2 atmosphere. And temperature is 25 degrees Celsius. And
Temperature is how much? Where is the temperature?
25 degrees Celsius.
Oh, 25 degrees Celsius. Okay.
And it's
Okay.
the question stating that a gas-filled balloon at those specs is allowed to rise to a stratosphere where the temperature and pressure are, so it's giving new temperature and new pressure.
So because they are giving new, so I'm putting 111 for the previous case. Okay.
Yep.
And now putting the new P2. What is the P2 now?
The new P2 is 3.00 times 10 to the minus 3 power atmosphere.
Okay. What is the
Temperature is
temperature new?
negative 23 degrees Celsius.
And what they're asking, final volume. Am I right?
Calculate the final volume. Yep.
Okay. First of all, do I have to change some unit?
Yes,
Any unit?
we'll do kelvins. We'll do Celsius to
Okay.
Kelvin.
273. I will get 298 Kelvin. And let's add 273 here. And what you will get?
Was it 305? 273
273
plus.
no.
298. Sorry.
Minus 273. 250. Because this is
Yep,
minus
250.
223, okay? So minus and plus will give you 250. Now everything is okay. We don't need R. Which equation I have to use? Formula.
I'd say Charles' law.
No.
No?
It's a general gas equation. Because everything is changing. General gas equation. But with general gas equation, there is two forms of general gas equation. One is PV is equal to nRT. Another one is P1 V1 over T1 is equal to P2 V2 over T2.
Okay. So
Which
PV,
one I will use?
Yeah, the general gas, it says no constant except the R. Okay.
We can use this one also. Because this is going to be easy. Otherwise you have to first calculate n and then again use another one.
Mm-hmm.
So it's going to be two steps. So we can use it one step with this general. And in this case we don't need R. But you can use any pressure, any volume unit, but temperature in Kelvin. So let's do this one. You have to calculate the V2. Can you first rearrange this?
Yep.
What will be at the top and what will be at the bottom?
Yep. Just a second. So V2 is equal to P1 V1 T2 over
P1 V1 T2, very good.
over T1 P2.
That's right. And now plug in the value.
All right.
P1 is 3, no, what is the P1? 1.2, right?
1.2. Yep.
1 point, and let's write the unit also. So if you make mistake, what is the V1?
2.50 liter.
Liter. What is the T2 we have?
250 Kelvin.
250 Kelvin. 250 Kelvin. Now, what is the T1 we have?
298 Kelvin.
298 Kelvin. What is the P2 we have?
3.00 times 10 to the minus 3 atmosphere.
Minus 3 atmosphere. Let's first check the unit.
Okay.
ATM cancel. Kelvin cancel. And the only unit still there is liter,
Liters.
right?
Yep. Yes.
And we want the liter because volume we are calculating. So just use the calculator to get the answer. And how many significant figure we have to keep?
2.
2.
Based off of the pressure
1.2
P1,
atmosphere.
right?
Yes.
All right.
Okay, what's your answer?
8.4 times 10 to the 2 power liters.
Okay, 8.4 times 10 to the power
2
2
liters.
liter. Okay, you're right.
To give 840 liters.
Yes, with 40 liters.
All right.
Clear?
Yeah, it's definitely clear now. I have to definitely drill it into my head that the general gas equation can be rearranged to that P1 V1 over T1, and
Yeah, you don't have to memorize. You can just know how to rearrange them. Okay, any formula in physics, chemistry, you all doing the rearrangement. Okay,
got it.
but be careful about the units. Okay.
Will do.
Okay, like how many significant figure and units.
Yep.
What about the next one?
39. All right, I'll give you the data. It's saying an ideal gas originally at pressure 0.85 atmosphere.
Pressure is how much? 0.
0.85.
And look here, I don't put 1 and 2 in the beginning, right?
Yep. No, I
Only
agree
put
with
when
that.
I see another pressure, another things.
I agree with that. Yep. I'm gonna adopt that when I'm going through these problems. All right, so and temperature is 66 degrees Celsius.
Mm.
And it's allowed to expand until its final volume, pressure, and temperature. So 94 ml.
94 ml.
Yeah, it looks like that's. I'm sorry.
And what is the final
Okay,
pressure?
it's given it respectively. All right, so it wants us to calculate its initial volume. So it gave us the initial pressure and temperature.
So because initial volume we need, of course not given there. So I'm going to put like this one, P1, T1, and let's take the V1 here. But they had not given, so putting question mark, okay? And the V2 is 94 ml.
Yes.
What is the P2 is?
0.60 atmosphere.
0 atmosphere. And what is the temperature?
45 degrees Celsius.
40. Do I have to change any units?
Yes, the Kelvin.
And they are asking the initial volume. Okay. Kelvin. So plus 273. Plus 273 here.
Yep, 73 plus 5. Okay.
273 plus 66.
Yeah, all right. T2 is 318.
T2 is 318.
Yep. Yeah.
Okay. Kelvin. So now we are all set. We can use the ml. We don't need to use converter because we are not using the R. What formula we have to use for solving this problem?
It reminds me of the last one that we did, so I'm going to say rearrange the general gas equation.
P1 V1 over T1
T1, yeah.
is equal to P2 V2 over T2. Now because we have to figure out V1, so rearrange for V1 now.
All right. P1 is equal to P2 V2 times T1 over
P2 V2 times T1 over
T2 times V1.
T2 times, no, V1 we have to calculate, P1. Okay. Now this one we have to, now plug in the values.
Oh, okay, I'm sorry.
No problem. P2 is, what is the P2?
P2 is 0.60 atmosphere.
What is the V2?
94 ml.
T1
is 339 Kelvin. 339 Kelvin.
339 Kelvin.
Yep.
T2 is how much?
318 Kelvin.
Kelvin. And P1 is
0.85 atmosphere.
Atmosphere.
So we're going to divide this
Now
by 1,000?
First let's unit, no, just, you don't have to do anything, just keep it. In this case you can use any unit for pressure and volume, but temperature of course Kelvin. K and K is also cancelled. And what unit is still there? Which unit is there?
ml.
So your answer is going to be ml. And I'll look the number by using the calculator.
Okay. And we're going to keep 2 sig figs. 71 ml.
71 ml, that's correct. That's the answer.
All right.
Is it clear?
Yep. Yes, sir. Yep. Yeah, I remember going when I first reached out to you a couple of years ago for the thermochemistry. You and I, you did an awesome job helping me out with all these, with everything actually. You know.
Your test is 4 and 5 chapter, right? form.
Yeah, it's going to be
I am
4,
also
5,
going
and
to send you
6.
the,
So,
you all maybe you have it, but otherwise I'm going to send it again.
yeah.
Some gas problems things, okay?
Okay. Yeah, I would like
And
to do
yeah.
some
So because if you, it
problems.
doesn't matter if you know the method. It doesn't matter which book they use, which from where I will give the problem.
Hmm.
You can do that thing.
Yeah, I definitely
It's not.
need
Yeah.
I definitely need some practice with problems where I have to identify which formula to
Yeah. The
use.
main thing is you have to first identify the problem. Okay. What they're asking. Just I was telling someone yesterday, when you go to the doctor, the first step the doctor has to diagnose the thing.
Yeah.
It is the same thing is here.
Yep.
If you don't diagnose what they are asking, what you have to do, then you can't do the problem.
No, you're right. You're right. I, yep.
Okay, now
For sure.
5.41, am I right?
Yes. Yes. Yep.
Now make the data.
Yep. All right. So they're given pressure in millimeters of mercury, 772.
772 mm of mercury. And now remember, mm of mercury and torr are the same thing. If they give torr, it's the same thing. They also use the word torr for mm of mercury.
Got it.
So don't be confused. It's same thing.
But so it'd be 1 atmosphere is 760 torr,
Yeah.
right?
Torr. Yeah.
Okay. All right. So the data given is temperature is 35 degrees Celsius, 35.0.
Mm.
Okay, and the volume is 6.85 liter.
So far looks three significant figures they are using. Now what they are saying.
Oh, okay. It's asking to calculate the volume at STP, standard temperature and pressure.
Calculate the volume at STP. Now in this case what I'm going to do, I'm going to put subscript 111 for them. And now for STP I'm going to put the 2. What is the standard pressure? P2.
Is it 1 atmosphere?
1 atmosphere, but in mm what is? You're right, 1
Oh,
atmosphere.
760 millimeters of mercury.
760 mm mercury.
Yep.
What
yep.
is the standard temperature?
Is that one 0 degrees Celsius? Or
0 degrees Celsius, you're right. And V2 we have to figure out at standard temperature pressure.
yep.
So that's I'm doing. Because STP is giving you T and P. So I'm putting 2. Do I have to use any unit and change any unit?
Just the temperature.
Temperature. So just add 273. And see what you will get.
Yep. All right, so we're getting 308 Kelvin for T1.
308 Kelvin. What about the T2?
It'd be 273 Kelvin.
Okay, so now we have everything. What formula we have to use?
I would say that rearranged general
Well,
gas
first
equation.
do it without rearrangement.
Okay.
T1, V1 over T1, am I right?
Yes.
Because the information look this fits better.
Yep.
We have to calculate V2. Can you rearrange this thing?
Yes. V2 is equal to P1 V1
Mm.
T2 over T1 P2.
That's good. Okay, now just plug in the value.
All right.
First pressure is 722 mm, am I right?
772.
Sorry, 772 mm. Mm of mercury.
And the volume
V1 is
6.85 liter.
6.85 liter. T2 is how much?
273 Kelvin.
273 Kelvin. Now denominator is T1 is how much? 308 I think.
308 Kelvin. Yep.
308 Kelvin. And what is the P2?
772 millimeters of mercury.
No, that was the
I'm sorry.
P1.
Yeah,
PT.
you're right. It's 760.
760
760.
mm mercury. Now let's first look the unit. M of mercury cancel. Kelvin cancel. What is the unit is still there?
Liters.
And we want the liter volume. Volume is in liter. Okay.
Got it.
Now just solve this thing and you will get.
Okay, and we're doing 3 sig figs. Okay, I'm getting 6.17 liters.
Okay, maybe I made a mistake. Where it go? 85 times 273 divided by 308 divided by 760. Yes, what is the answer here? You're right.
6.17
One
liters.
That's right. That's the answer. Clear?
Yes. Yep. Yeah, it's
Now
good.
do this one
We got 4,
from the
3.
beginning.
Yeah.
Yes, this one. Okay, I will go to the next
5.43.
page. Okay. Okay, I will go to the next blank page.
Yeah, there's only four of them left. So after this 43, they have 3 left.
Okay.
Yeah, we're doing good on.
Yes. That's not. Don't worry, you will get best even in this. Maybe this time you are going to add 100.
I'm hoping so.
Even that one was 100. That's I would consider 100.
Yeah.
That's not a big deal.
Yep.
So now look, this one 5 point. Which one we are doing? 4-3.
4,
All
3.
right.
4, 3.
Okay. Now this one data tell me and also tell me the formula and everything.
Okay.
Think by yourself. Okay.
Yep. All right. So straight off the bat, the volume is 0.280 liters of a gas, and it's at standard temperature and pressure. So the temperature would be 0 degrees Celsius, or I'll just convert it right here mentally, 273 Kelvin. Okay. So I'll just do that right off the bat.
Okay.
And the pressure is 1 atmosphere.
Okay.
All right. And they're saying that it weighs 0.400 gram.
So mass.
The mass.
I'm taking like W is equal to how much? 0.400 gram. And what they are asking, molar mass.
Molar mass. Yup.
Molar mass of gas. I'm putting mn. Molar mass. How I can do this, do you know?
I was thinking about that density where it deals with density, but
No, we don't need any
yeah,
density.
Can't we rearrange the
First of all, we can do it in 2 step, or we can readjust the formula by changing a little bit. Both things you can do. Which formula is good first of all? Okay, just like I told you to go to the Google map in stoichiometry. Even if you don't memorize the formula, all of the formulas, that's okay. We can go like here, from mole to gram. You already know this thing.
Yep.
You go from mole to gram. And how we go from mole to gram? By the help of molar mass, am I right?
Right.
You need the molar mass to go to the gram from the stoichiometric problem. I'm going to use this one. So once I will get the mole, I can, and I already have the gram, I can go from gram to molar mass. So it means first step is I will get the mole. How many mole? Then I will use the mole and gram to get molar mass, right?
Yes. Could we do?
So it's
I was looking at your sheet and I see PM, like for pressure molar mass,
yeah. We can also
is
go
equal
directly there.
to mass over volume times RT. PM
V
equals
was
M
volume
over V.
RT.
RT.
Yeah, we can
Is
also
that one
use
that
this
we can
one if
use?
you want. Yeah, we can also use this. Okay, but I want you to know both things. But in case if you, because sometimes so many formula memorizing is difficult.
Yeah,
So you have to know that some. I will also give you the other way. Okay.
got it.
So
Yeah,
let's do
I'm
this
sorry
one.
for interrupting you.
No, no problem. So let's first do this one. You want to calculate m.
Hmm.
Can you rearrange m for this one?
Yep. Yeah, I'm gonna do the entire right side over pressure. So let's see. Yeah,
M is the same mass like
hmm
W tighter.
yeah. I'll
You
do
can see.
the molar mass is equal to the mass over volume times RT, and then all of that divided by the pressure.
Pressure one. Okay. If I plug in the value, how many grams they had given me?
No, like if I do,
How many grams? This is grams.
would would we put the volume up here or no?
No, no, volume is going to be
Or
here.
the P up here?
Mm.
No?
No, P is also going to be bottom because you want M.
Yeah.
So in molar mass,
No, yeah,
so
you're right. You're right.
cross it will go here in the denominator on the other side. Look, you want to get rid of P, am I right?
Mm-hmm.
So you have
Mm-hmm.
to divide by P.
Yep. No, you're right. I was just looking at it wrong. So that definitely makes sense for sure. Okay. So,
This is gram.
yep.
This is 0.0821 liter atmosphere Kelvin inverse and mole inverse, right?
Yes.
And also we need temperature. So temperature I am writing how much? 278, right?
273.
273, sorry,
Yep.
Kelvin. And the pressure is how much? 1 atmosphere.
1 atmosphere.
And volume is 0.280 liter, right?
Yes.
Look here at units.
Yes, it is.
Where is the atmosphere at? I'm checking something wrong. No, liter atmosphere. So look, atmosphere cancel, am I right?
Yes.
Kelvin inverse and Kelvin cancel.
Mm-hmm. Mm-hmm.
And now liter and liter is cancelled. What left? What unit left?
Grams.
And also something else, mole inverse, am I right?
Mole inverse. You're right.
And that's called go gram per mole, am I right?
Oh, and that is the molar mass.
That's the molar mass, okay?
Yep.
So look this one.
You're right. 32.019 grams per mole. And let's see, so they're giving us 3 sig figs to work with. Okay. So 32.0 gram per mole is equal to molar mass.
Okay, wait a minute. Why I have written 2.280? Oh, liter is in liter, yes. 2.280. 2.280. What is your answer? 32.0.
32.0.
Okay, that's the gram per mole. Okay, if suppose you don't know, memorize this formula, it's also okay. Let me, I will show you.
Mm-hmm.
First calculate, use the general gas equation, nRT, and calculate the N. What you are going to calculate? N. N is equal to PV over RT, am I right?
Yes.
You already have the P, 1 atmosphere. Volume is 0.280
Gram. Yep.
liter,
My bad,
and
my bad.
R is 0.0821 liter atmosphere Kelvin inverse mole inverse, and temperature you have 273 Kelvin, am I right?
Yes.
Kelvin and Kelvin inverse and Kelvin cancel, liter and liter cancel, atmosphere and atmosphere cancel, and only unit is there is now mole. So you get the mole. How many moles you will get in the first step? 0.280 divided by 0.0821 divided by 273. So I am getting the mole.
0.01249.
0.101249. Let's take this, all of them. Mole. Now we have to calculate the molar mass. The molar mass formula is, I am writing here, 0. You have to convert this in mole into grams. You have to convert this mole into
Grams.
1 gram.
Mhm.
So I am going to take like this one. I have the mole and I want the mole per gram, right? Per gram.
Yes.
So how I can do this? Just, you have the gram also. How many grams is given there?
0.400.
0 gram. So I'm writing this gram. And this gram is equal to 1 mole. Sorry. How many mole is equal to?
0.12 or
This is mole.
0.01249.
Am I right?
Yes.
If you solve this one, look here, it's a gram per mole. Am I right?
Yes.
So I'm just writing here. So you are calculating for 1 mole.
Yep.
So this, otherwise just leave it this one and just calculate this thing.
And it's
You
just-
will get gram per mole.
Yep. The same answer.
But yeah, this is the n, number of mole. We can also go like this. Dividing the mole by grams by mole and you will get this one.
Yep. Yeah, it's
So
perfect.
You can do it anyway.
Thank you for explaining both of those methods.
Okay, now let me also give you another thing.
Yep.
Okay? 1 mole, the same question. You know everything. The same question 5.43.
Okay.
1 mole of any gas, at STP occupy how much volume? That's called molar volume. Do you know?
Is it 22.4 liter?
Yes, 22.4 liter. Okay. So it's very simple now. For even without doing all those things, I can do like this, starting with this 0.40 gram. Am I right? Occupy how much volume?
They gave us 0.280
0.280 liter. Am I
liters.
right?
Yes.
Now what I'm going to do is, how much gram is going to be there if we have 22.4 liter?
Oh, okay.
Because 1 mole occupy this at STP, am I right?
You're right. Yep. Yep.
At STP. If I do this, what I will get? Liter cancel in gram per mole, am I right?
Yeah, I'm doing it out right now.
And that is the unit of molar mass.
32. Yep.
Okay? We can do it many ways.
Wow.
It's not complex.
Wow. That's
So just like you are taking
That was
turnpike,
really-
you are taking local route, anything, you can go there.
that's super fast. I can't even believe it.
Okay, yeah. Because we know that at STP, 1 mole is equal to this liter.
And that's for any
So I use this
compound.
concept.
Is that right?
Yeah. So if that gram is containing this much liter, how many gram will contain occupy 22 points? That will be the molar mass.
Wow. That's freaking good. I'm right.
Okay. 5.47. Okay.
Yep. Wow. All right. So they're giving us volume. I'll give you the data. Yeah. And this is a 2-part question. It seems like. So
Now
they-
you tell me what is given and what they are asking. Everything you tell me.
Yep. Volume is 2.10 liter.
2.10 liter. You're right.
Mass is
Mm.
4.65 gram. And pressure is 1.00 atmosphere.
Mm.
And temperature is 27 degrees Celsius. 27.0
Correct.
Celsius.
And if you add 273, you will get 300. Am I right?
I'm sorry. Yes, 300 Kelvin. Yep.
Calculate the density. What you have to calculate?
Density.
Density. And also you have to calculate the molar mass of the gas.
Yep.
Okay, I already had gave you the formula for this. You can do it without that formula, but because we have gram, but you look the formula making this one.
Mm-hmm.
General gas equation is PV is equal to nRT, you know, right?
Yes.
N is the number of moles, and mole is equal to the mass over molar mass.
Yep.
So I'm writing mass M and molar mass MM.
Yep.
So I plug in this value PV is equal to M over molar mass into RT. Now I want to bring the molar mass, because molar mass they are asking molar mass, right?
Yes. Yep. As one part.
Asking molar mass. So PV is equal to, sorry, not PV. If I bring the molar mass here, molar mass, and I will put this one M over V, mass over volume, RT. This is going to call density. This is what, this is mass over volume is density. Is M over, sorry, not M over, this is density D. But the problem is, can I use this thing? Is it possible? Because I don't know the molar mass. How I can get the density? They are asking both of them.
Mm-hmm. Mm-hmm.
So formula is not going to work here.
We could do molar mass is equal to.
But we can do it other way. Why?
Yeah.
What is the given in the beginning? If you see, what is given here? You have volume, pressure, temperature. Am I right?
Right.
I'm going to put 1, 1, 1 here. I'm going to put what? 1, 1, 1.
Okay.
And now what I'm going to do is, I'm going to put like V2, I'm going to calculate, put the T2, which is standard, 273 degree Kelvin, and P2, which is standard, is what? 1 atmosphere. Can I do this thing? So what I'm doing is, in the beginning, I'm calculating the volume at STP. These are what? STP. These are what? STP, right?
Yes.
So let's do this one. And for that purpose, we use the formula. I'm again rewriting it. Volume is 2.10 liter. T1 I am taking 300 degree Kelvin, 27 converting into Kelvin.
Yep.
And P2 I am taking 1 atmosphere. Now I am taking another one, V2 I am calculating. P2, sorry, this is P1, sorry. P1. P2 is also 1 atmosphere for standard. So even I don't need the pressure, I can cancel that one directly. And you have to calculate that T1 is 273 degree Kelvin. So let's calculate this one first. V2. P1 V1 is equal to P2 V2 over T1 over T2, right?
Yes.
What is same? P1 and P2 is same, right?
Yes.
So I can cancel this one. They are already same. So just V1 over T1. So what now left? You have to calculate V2.
Yep. V2 is equal to V1 P2 over T1.
Very good. Now plug in the value. V1 you have 2.10 liter. P2 we have how much?
Let me see.
No, P also we already cancelled. Why I'm writing P2? Yes, I was thinking. V2 is equal to V1
Over T1, yeah.
Oh, sorry, P1. No, this is T1, sorry. This is T2, not. I made mistake here. This is T2. T2. So this is going to be, V2 is going to be V1 T2. V1 T2, sorry. T2. Now, what is the T2? 273.
273. Yep.
What is the T1? 300K. K cancel, and you will get the liter. Let's try this one. 2.10 times 273 divided by 300. How much is that? This one?
I'm getting 1.911 liters.
You got this liter, okay?
Yes.
Now this volume is at STP. This volume is at
STP.
STP. Now what we are going to do is here is in the next step. You already know 1 mole of any gas at STP occupy how much volume?
22.4 liters.
I am going to use this concept to get the molar mass. So let's start this one again. How many grams was given there?
4.65 grams.
And how much volume is given there?
2.10 liters.
And now just multiply, but you want 1 mole occupy at STP how much?
22.4.
STP, okay. So liter cancel, and you will get gram per mole, am I right? And that's the molar mass. Calculate the volume at STP, then use that one.
Right.
Oh, no, sorry, I made mistake something. Hold on. This is not the liter at, we have to use this liter, which we have calculated.
Okay.
1.911, because that's the volume at STP. 1.911.
4.65 times 22.4 divided by 1.911. All right. So I'm getting 54.505 grams per mole.
How much you are getting? 54.5, am I right?
Yeah. Yep.
So that's the molar mass, gram per mole. Now they are asking density. So density, you don't have to use the formula. Density is equal to what?
Grams over.
Mass, grams over liter for the gas.
Yeah.
Volume.
Mm-hmm.
You will use this gram, 54.5 gram, and 1, because so 1 mole at STP, what is the volume? 22.4 liter. Because this is volume at STP.
Okay. So that's.
Are they asking, okay, wait a minute, they are asking, molar mass is okay, but are they asking the density at STP or at that temperature? They are not asking at STP density, right?
Right.
Okay, so we don't, because they are not saying at STP. Then you can use the formula. PM is equal to TRT, am I right?
Yes.
Now you can calculate density. Density is equal to what?
PM over RT.
P is how much? 1 atmosphere.
Yep. 1 atmosphere.
And molar mass is how much?
54.5. Yeah.
Gram per mole, you can say. And R is 0.0821 liter atmosphere, Kelvin inverse, mole inverse, and temperature is
We got
300 degree Kelvin,
Yep.
right?
Yes.
Liter, let's see what unit we can cancel.
Atmospheres.
Gram per mole. Okay, so mole inverse cancel. Mole. Atmosphere cancel, right?
Yes.
And we end up with grams per liter. And that's the density. Use the calculator to get the answer.
You get 2.21.
Two point
21 grams
one.
per
Yes,
liter.
you're right.
Okay.
Yes. Because why I skip the other one? Because they are not saying asking density at the STP. If they ask density at the STP, I can just take the molar mass and divide by liter, 22.4. But I see that they are not asking at STP.
Got
Okay.
it. Yeah, that one was the most involved one.
Yeah, you have to practice this again. Okay.
Yep.
Why? Because we can use the formula because they are not giving the molar mass. They are not giving us the density. So then I went another channel, another route. I took the molar concept that 1 mole of any gas occupies 22.4 liter. Okay. So first I calculated the volume at STP, then I calculated the molar mass, and then I use this one again to get that one. A little complicated, but it's a good question. You can practice this. That will be like a brain practice, how we can jump here and there.
Yeah. Yep. Yeah, that one's definitely a good one.
Yes. Now we have two questions, right?
Two of them are left. Yep.
Okay, let's finish this one.
All right. So 5.57.
Or 5.57.
Yep. All right, I'll give you the data. So it's looking like a mixture of gases. Looks like 3 different gases. So saying the total pressure.
Okay, can you, and the number of moles of gases are this. Can you just identify what is the problem is? Just like I told you, diagnose the disease. What is this?
This one needs us to. I'm trying to remember the law, but it's the one where it's okay. Dalton's law, partial pressure.
Yes, this is Dalton's law of partial pressure.
Dalton's law. Okay.
So this is Dalton's law of partial pressure problem.
All right, so it gave us the total pressure, so TP, and that's 1.50 atmosphere.
Okay, let's try this one. Partial pressure, which of this total pressure is how much?
1.50 atmosphere.
The number of moles gas, let's say CH4 is how much?
CH4 is 0.31 mole.
What about the other one?
0.25 mole for C2H6 and 0.29 mole for C3H8.
.29. Okay. What is the total moles?
Total moles is going to be, let's
Add
see,
all of
3,
them.
4, 5, 6, 7, it'll be 8. 0.85. Are you getting?
I'm getting 2.1. 2.10. You have to add, oh, so, no, sorry, I'm wrong. I added the 1.50 also. That's the mistake I did. I have to add only more. 0.31 plus 0.25 plus 0.29. How much you told me?
0.85.
0.85, very good. Okay, so now 0.85 is the number of total moles.
And it's
Now
asking,
look the formula. You tell me what to do. Calculate the partial pressure of the gas. I want you to figure out what formula we need.
all right, just a second, I'm looking at it.
And I'm writing the individual partial pressure like this. CH4 you have to figure out. You have to figure out C2H6. You have to figure out C3H8. How I can solve this?
Okay, so they all have to equal out to 1, is that right? Oh, wait. Hold on.
Not equal out. No. Look another formula.
I'm thinking that we have to use a mole fraction. Just a second.
But we have a mole and total mole, so we don't need to calculate mole fraction. We can do it even directly.
All right. I just have to
Look
look
at
at
the
it
formula.
for a few moments. So P equals P1 plus P2 plus P3.
Look any formula, but PA or PB, something like that. Do you have that formula?
PA equals P to N over A, or P
P
equals.
is equal to PT in like total pressure,
Okay, so
NA over NT,
so-
right?
I see like 4 of them. So then I see PA over
Yeah, 4
PB
of
is equal to NA over NB.
Yeah, and we also you can use that one.
Which
But
which
you
one?
also see like the total pressure, NT.
Yes, I see that.
Okay, use that one. Okay, use
Okay.
that one. PA is like any gas, so I'm going to use CH4.
It's been
PCH4.
a long time for me doing any of these problems or seeing these
Okay,
formulas.
what is the total pressure given here?
1.50 atmosphere.
P is the total pressure. What is the moles of CH4? 0.31, right?
Yes.
And what is the total moles we have calculated?
0.85.
The ratio is called the mole fraction. We don't need to calculate, we will directly do it here.
Okay.
Tell me, 1.50 times 31 divided by 0.85.
0.4. I'm sorry. 0.55 since we're gonna round to 2 sig figs.
0.54755, okay? No, 3 significant here. Oh, because the moles is 0.31, right?
Mm-hmm.
Okay, you're right. 0.55. Okay. Otherwise, in the beginning, we can just keep this one, 0.55 atmosphere. What about the next one?
We'll do 0.25 over 0.85 times 1.5.
1.50 first. 1.50 times 0.25.
Yep. Over, yeah. I'm getting 0.44.
How much? 0.44.
44.
Now the last one.
All right. 0.29. Yep. Zero 0.51.
And now you can verify whether we are right or wrong. Add all of them and see if it is equal to or very close to total pressure.
Yeah, it's equal to or very close. It only because I retained the entire answer for this one, and then I added this and added this. It comes out to a little bit over it, but it's negligible amount. So zero.
I'm getting the exact 1.5.
Yeah, exact. Okay.
Okay. So this means correct. We already done this thing. So look, we are using the Gartenstaff partial pressure, this one, and getting all of them. This gas, this gas, this gas, all of them.
And that's the pressure, the partial pressure.
Partial pressure. And this is MA mean the moles of this gas, A. So because you are taking CH4, take the moles of CH4, take the moles of C2H6, take the moles of C3H8, and then you get that. And the total will be equal to the total pressure we have given. This one.
Got it.
Now the next question is, now you tell me what is this question.
All right, I just gotta read it. Let's see. It's giving me volume. Yeah, it wants us to calculate the total pressure of the mixture and calculate the volume in liters at standard temperature and pressure occupied by helium and neon if the nitride or the nitrogen is removed selectively.
Yeah. These questions like a little bit thinking questions, okay? We have to make a plan to solve this one.
Okay.
But first you have to identify what is the problem. It's related to what problem?
It's the only thing that comes along is Dalton's law. So
Yeah, because I see the mixture of gases, am I right?
right. So
And in this type of problem, it's always good idea to make a picturize those things.
yep.
Okay, like those things. So like I know the flask is how much is given there?
2.5
2.5
liters.
Okay. Okay. And temperature is what?
15 degrees Celsius.
15 degrees Celsius. mixture of three gases are there, N2, helium and neon. And what are the partial pressure? Helium is at, no, nitrogen is at
0.32.
0.32 atmosphere.
Yep.
Helium is at 0.15 and neon is 0.42, am I right?
Yes, you're right.
Atmosphere. Calculate the total pressure. First you have to calculate what? Total pressure. So I am going to first calculate the total pressure. The first part they are asking total pressure.
Mm-hmm.
I am writing the total pressure PT, or you can just write P. It's no problem. How we can calculate the total pressure? For this type of problem, first of all, look, they have given the mole or not? No.
They didn't mention anything about the moles, so they gave the
Okay, no problem, but they gave the total.
they gave the partial pressures.
So no problem. PT is equal to P into plus P helium plus P neon. Dalton's law of partial pressure. Add all of them.
Mm-hmm. All right. .89 atmosphere.
0.89. That's the answer for this one. Simple Dalton's law. Now they are in the B part. Read again the B part.
Calculate the volume in liters at standard pressure. STP occupied by the helium and the neon if the nitrogen is removed selectively.
Okay. First of all, we have to figure out how many moles of helium and neons are there in the beginning, in the container. How we can get that one?
Wait, you said how many
We know
moles?
that, yes. How many moles of these things? Because that, then we can calculate the volume, okay?
Okay.
Or we can calculate that, we don't need to calculate separately.
Mhm.
We can also calculate like the moles of together, helium and neon.
All right.
Helium
So
and neon together, okay?
so we could do the general gas equation, and I'm thinking since they
But what is the total pressure total of helium and neon together?
it'd be. Hold on a minute. We're removing N2. Okay.
Yeah.
So 0.42 plus 0.15 is 0.57.
How much is this one? 0.57, right?
Yeah, and that would be the new total pressure.
The pressure or due to helium and neon, right?
Right.
Okay, we already know the temperature and pressure at that condition. We are going to use general gas equation. We are not doing separately, we are doing together with these gases, okay? Because we want the volume, moles, and N is equal to what?
Mole. I'm sorry. Yeah, moles, which is grams over gram per mole, or
So the pressure at that time was the total, not the total pressure, but this pressure. So how much?
0.57.
0.57 atmosphere. Volume, because the container volume is the same at that time. How much was the volume? 2.5 liter, right?
Yes.
And R is 0.0821 liter atmosphere, mole inverse, Kelvin inverse, and temperature is 15 degree means how much? In Kelvin.
Sorry.
288
Yeah, 288.
Kelvin. So look here in this Kelvin cancel, and atmosphere, liter, and you will get the mole, right?
Mm-hmm.
Mole will go up and become mole. What is the number here you are getting?
0.57. 0.060.
0.060. Okay. That's I'm taking the mole.
Mm-hmm.
Once I got the mole of helium and neon,
Mm-hmm.
Now I'm going to calculate the volume at STP. Now I'm calculating what? Volume at STP for these helium and neon. Helium and neon. Again using the general gas equation. Formula V is equal to, sorry, and I forget N. nRT over P, right?
Yes.
But now you have to use the temperature and pressure standard. Temperature standard is 273 degree Kelvin.
Mm-hmm.
And
Right.
pressure standard is 1 atmosphere. Plug in the value. And you already have got 0.06, right?
Yes.
0.0821 times 273 times 1 atmosphere. And look what you will get.
All right.
How much you are getting?
I'm 1.34.
1.24. So look the answer. It may be a little bit different because we are rounding and not picking up all the things. But it's going to be close to this one. Look the answer.
Yep. Just a second. And this was volume, right? So it'd be in liters, 1.34. All right. I'm gonna check
Or
now.
maybe 1.3 only because 0.060 is a 2 units only. 2 significant figure.
Yeah. I'm just scrolling through the PDF. Just a second.
So I think 0.1, 0.3 liter is going to be. Keeping 2 significant figures.
Yep. Yep. Still scrolling through the PDF. Just a second.
No problem.
Yeah. It gives really long explanations.
But what is the answer?
Okay. So they're saying the answer is 1.4 liters at standard temperature of pressure.
1.4.
And the only
We are getting-
the only difference that I'm seeing here is because they calculated the moles to be. Or let me see. No. What did they do different?
Maybe they took all of them in the original things, like all of them, which they ignored that one.
They did.
Let's see from
They did V2 is equal to 0.57 times 2.5 times 273 Kelvin divided by 1 atmosphere divided by 288 Kelvin. And then they got 1.4 liter. So I'm going to see what that comes out to. 0.57 times 2.5 times 273 over 288. Okay, so it's coming out for them 1.35. And then that's why they're rounding to 1.4.
No, that's okay.
So,
Because even if I take all the digits here,
mhm.
all the digits here in this case, and go to this place, so I can write without deleting anything 0.0821 times 273, and even I can take 273.15 if I want.
Mhm.
I am getting 1.35 something, so that's rounding to the 1.4. Yes. If I don't delete this one all, take this all, I will get 1.35078 something.
Mhm.
So rounding to 371.4. Clear?
Yep. Yeah,
And
it
in
was,
that case, take all the digits from here. There. Don't delete. That's better. Always don't delete it. Take the units and round it at the end.
yep.
Okay. But it's clear how to do this question.
Yep.
What we did first, we calculated the total pressure. That's easy. Now we're taking the by using that one. We are already know the partial pressure. Instead of calculating separately, I add them and I calculated the total number of moles of these two gases, which is 0.060 something. Then I did the volume at STP. Took all the digits here and these temperature, pressure, and you will end up with 1.4 liter. Okay?
Got it. Yeah, that was good. That was real good. That was a good productive session. We completed all of them, and the timing is just under 2 hours. So
So any question about this?
no, I definitely am gonna be practicing them. So if you have any other example problems that you can send to me,
No, I'm going to send you. I'm going to send you the. Maybe you already have, but I'm going to send you the gaseous problem.
yeah,
And you already have the formula sheet, right?
yeah, I got the formula sheet. If
Okay. So I'm going to send you the problems. Okay.
please,
You
yeah,
will try to solve those.
and I'll send you the results. Give me a couple days because
Yeah.
I gotta prepare for an exam that I have on Tuesday. So I'll probably
Okay,
send you the
no problem.
results. I'll try and have it finished for Tuesday. Okay.
Yes. So just practice all these two are not difficult. You can easily get 100. It's very easy.
Yep.
I only see these two which is you have to like a brain storming something like that.
Mhm.
Otherwise, even these are not too difficult. It's easy.
Yep.
Just you have to think.
Got it. Yeah. Thanks a lot for your time
Okay.
and
No problem.
you know working these problems through with me. I appreciate it
Okay.
big time.
Okay.
You're the best.
Okay.
Have a
Have a
wonderful
nice day and
have a wonderful day,
good luck for
Jafri.
your tests, okay?
Thank you. Thank you.
Bye.
Yep.
Bye.